So today we are learning all about empirical formulas. So if you think about what a chemical formula is first, a chemical formula is the thing that tells you the actual number of each element in one molecule of your compound. So let's say we've got glucose here. Glucose has 6 carbons, 12 hydrogens, and 6 oxygens in one glucose molecule. And here's a picture of a glucose molecule right here. You can see the 1, 2, 3, 4, 5, 6 carbons, the 12 hydrogens around there, and the 6 oxygens around that molecule. So glucose has literally 6 carbons. That's what that means. If we do an empirical formula, what we're going to do is take that chemical formula and put it in lowest terms. Just like you put a fraction in lowest terms, it's the same idea. And the point of an empirical formula is to tell you the ratio of each element in the compound. So if glucose has 6 carbons to 12 hydrogens to 6 oxygens, if I put that in lowest terms, what I really see here is that there's double the number of hydrogens as carbons, and that there's the same number of oxygens as carbons. So I can put that in lowest terms by seeing, well, what common number can I divide everything by? And that would be 6, right? 6 over 6 would be 1. There is just 1 carbon. 12 over 6 would be 2. There's 2 hydrogens for every 1 carbon. And 6 over 6 with the oxygen here would be 1. There's 1 oxygen. So there's a ratio here of 1 to 2 to 1. So 1 carbon to 2 hydrogens to 1 oxygen. There's not really 1 carbon in glucose, right? There are 6 carbons in glucose. The chemical formula is the real deal. That tells you how many of each element there really are in the molecule. But the empirical formula tells you the ratios of one element to the next, which can be also really useful, especially when you're thinking about things like percent composition. So let's do a few examples. What's the empirical formula for hydrazine? The formula for hydrogen, so this is the real chemical formula for hydrazine, is H2N4. That means in a hydrazine molecule there really are 2 hydrogens and 4 nitrogens. To put that in lowest terms, what you're going to want to do is divide by a number that both of these are divisible by. And that number would be 2, right? I could divide 2 by 2 and I could divide 4 by 2. So that's going to give me 1 hydrogen, 2 divided by 2 is 1, and 2 nitrogens, 4 divided by 2 would be 2. So the empirical formula is HN2. What it tells me is that there's double the number of N's as H's, double the number of nitrogens as hydrogens. It does not tell me, that empirical formula does not tell me how many hydrogens or how many nitrogens are in a hydrazine molecule. For that, you need the chemical formula. This is the chemical formula. But the empirical formula does show me the ratios of hydrogen to nitrogen. Let's do another one. So here's benzene. Benzene is a ring of 6 carbons with 6 hydrogens around them. So there really are 6 carbons in benzene and there really are 6 hydrogens in a benzene molecule. But if I want to find the empirical formula, I can look at the ratios. So for that, I put things in lowest terms. I can divide both of these by 6. That's the sort of common number I can divide both subscripts by. And that gives me just 1-to-1 ratio here of carbons to hydrogen. So it would be CH, 1C, 1H for the empirical formula. And that's the basic idea of what an empirical formula means.